Hello, my name is Anmol Gerola, and my topic for digital assignment 3 is Automata theory in game theory. And I picked this topic because I like making games a lot, and there are plenty of games under my name. Me taking computer science for bachelor's is because of the reason because I used to play a lot of games and wanted to one day make them myself. So I picked up this topic. So the this topic is pretty interesting as when I was researching, I came upon quite a lot of information about it, and I've tried to include everything that I've learned. There were many topics I learned after this topic was given to me, and there were some I knew before. Learning automata theory. So, in today's game, like what we want is what all the players want is innovation. So, I think this is the best example of innovating because what the game does is it collects all the past information of how the player has been playing the game and is making the game difficult for the player in the future. So basically the game learns from the player and make it difficult for them, and they just have to come up with something new. Some of the examples of games which use this automata are Will You Snail. So Will You Snail is a fast-paced platformer. So it's one of the uh, YouTuber who is making it, and he unraveled, like he showed how he's doing it. So what he does is over here what you see is two paths. One of them is a normal calculation of the trajectory. So his path will be captured, and this one is where he should be landing, but the other path that you can see is where he can use his double jump, and this is where learning automata comes in because he has calculated what the player might be doing in the near future. Other game is Echo. This is a pretty big game and has been released on the consoles. So it's a very innovative game where all the computer controlled players are very much informed about how you have been playing the game in the past and is evolving. They are always evolving in such a way that they intercept you in a way you have been cheating them on. So it's a pretty interesting game. So finite state automata. So what happens over here is that you have finite solutions. It's like when you have a puzzle game and there is more than one solution, you have to use finite state automata. And there's another application where you have games with multiple endings. So your current state matters a lot, and it depends on your current states where you might end up at the ending of the game. So some examples are Far Cry 4. So it's a pretty basic game, like not a basic game, but has used the automata in a pretty basic way because it has only two endings. But one of the more complex version of the complex example for this automata would be Witcher 3. So it has a lot of endings, more three main endings and plus many other smaller endings which affect the ending in very small ways, and it has a lot of like every dialogue you speak might change your trajectory of how you are going to end the game. There are plenty of, like, it's a really good game. I've played it. There are more examples of games like Witcher, like the Skyrim. It's really good, and there are plenty more. So cellular automata. So in this automata, what happens is that you have a neighborhood, and that neighborhood matters. This All the blocks are really affected by all the neighbors. These are some examples of how what you can call our neighborhoods. So this another game called Conway's Game of Life. It is really amazing. So it's also known as the zero player game. And what it has three rules. If there's a block and it has two neighbors, the block will live. If it has only one neighbor, the block will die. And if there's a block which is dead but has three neighbors, it will live again. It will take birth. So here's an example of how it happens. So what you can see, this middle block has two neighbors, so it will live in the next time unit. So it's there. And this block has three neighbors, which are these three. So it will take birth, and it has taken birth. And this block has the same rules like the other one. So this will be the final results. As this one has only one neighbor, it will die. So what we have made is an oscillator. So it will keep on shuffling between these two states, and it will look as if it's oscillating. There's another example, and it's a really nice example because it demonstrates, because the previous one is simple, this one is little complex. And if you're watching this video and would like to guess what the future states will be, you can just go back and look at the rules and come back and solve it. Like how might this be, how this might change over some, like, look for a lot of periods of time because it's pretty interesting. So now I'm showing what happens. I'll play it. Like, I have a lot of slides, like one of what happens. Okay, I'll show it to you. So what we did was we made a glider. It moved, and you can make things like this in Convoy's game of life. So it's a zero player game because you don't do it, it's automatically doing it. It has created a system out of itself where it moves. So it's a glider. So but there's a thing, you don't really have to make a glider yourself, because you can make another system out of the complete grid which makes glider on its own, and it will keep on making glider. And this is just an example, a more complex example, but there is more to it, because you can make more systems, a system which can even make spaceships. These little things are spaceships, and they are created using our system that we have created. And this is an example of what how cellular automata can be used for making games. So Cell Machine is like made by Sam Hogan. Sam Hogan is the same YouTuber whose videos I have showed you over here. So all these little blocks actually mean things. If you are in contact with them, they will, like this one rotates you, this one pushes you around, changes your direction and all. But there's another game, Baba Is You, which is pretty interesting. Is one of the my favorite games. I've not played it, but the concept is pretty good. So what happens over here is that these are blocks, and if key is open, like you have to create these sentences. Like over here, it says wall is stopped. So if you collide with a wall, you will stop. You cannot cross them. But you can, what you can do is, if it was not covered, you can just remove wall from the sentence, and wall won't stop you anymore. So door is shut, which means the door is closed. If you remove door from there, you will be able to just pass through the door because it's unlocked now. And like key is push, like means that you can push the key. If you remove push from the sentence, you won't be able to push the key anymore. And if key is open, it means you can just drag the key to the door and door will be unlocked. But if you somehow change this word key, you can drag these objects, and if you remove it and place something like wall is open, so you can just use a wall instead of key to unlock the door. And to win, flag is win, which it's a sentence, so you can just remove flag, and flag is win to door is win. So the final objective will become that you have to reach the door. So this is a pretty interesting game using cellular automata. There's more. This is a pretty famous game, Minesweeper. And back in when like we had Windows XP, we had this game for free in our computers. So what? But most of the people back then did not know how to play it, and I don't think they still know it pretty well. But I really like to play this game sometimes. And what it does is neighborhood matters the most in this game. Like it's an amazing game, a master game. Like you have this cell over here, and it says three, which means it will have three bombs around it. So you have to predict their position and mark them as flag. You have to completely do it. So there are some tricks like it says one over here. So you have to look for the environment, which is the entire neighborhood. So you have only one block which can be accessible. So the bomb must be over here only. So this is how you play it, and that's it. Thank you so much.